Solution. First, rewrite the integrand. Try to express the integral in another form such that trigonometric substitution is readily applicable. Remember that there is a trigonometric substitution rule for an integrand of this form. Complete the square of the quadratic polynomial. Add 16 so that the quadratic polynomial ahead becomes a perfect square. Subtract 16 so that the value of the radicand does not change. Express the quadratic polynomial as a square of a binomial. Note that 16 is equal to the square of 4. Second, formulate a trigonometric substitution rule. Let x plus 5 be equal to 4 times the secant of theta. This means that the secant of theta equals x plus 5 divided by 4. Let us visualize this substitution rule using a right triangle. Let theta be one of the acute angles. From trigonometry, we know that the secant of an angle is equal to the length of the hypotenuse divided by the length of the adjacent side. Because the secant theta is x plus 5 divided by 4, it means that the length of the hypotenuse is x plus 5, while the length of the adjacent side is 4. Using the Pythagorean theorem, the length of the opposite side is the square root of difference of the squares of the length of the hypotenuse and the adjacent sides. Let u be equal to x plus 5. The differential of u equals the derivative of u with respect to theta times the differential of theta. Thus, du is equal to dx, which is equal to 4 times the secant of theta times the tangent of theta d theta. Meanwhile, the tangent of theta is equal to the length of the opposite side divided by the length of the adjacent side. This means that the square root of the difference of the square of quantity x plus 5 and 4 squared is equal to 4 times the tangent of theta. We chose to express this quantity in terms of the tangent function because it would be easier to combine and integrate this factor with other factors in the integrand, as we shall see next. Third, write the equivalent trigonometric integral. Convert the integral in terms of x into an integral in terms of the new variable theta by using the substitution rules we just formulated. Multiply 4 and 4 and move the product in front of the integral sign. Combine like factors. Use a trigonometric identity to express the integral in terms of established integration rules. Distribute the factor by multiplication. Fourth, integrate using an appropriate technique. In this example, the integrand can be integrated using two techniques. Using integration by parts, the integral of the secant cubed of theta d theta is equal to 1/2 of the product of the secant of theta and the tangent of theta, plus 1/2 of the natural logarithm of the absolute value of the sum of the secant of theta and the tangent of theta. Meanwhile, the integral of the secant of theta d theta is a basic trigonometric function rule, which is equal to the natural logarithm of the absolute value of the sum of the secant of theta and the tangent of theta, plus c. Substitute these expressions into the indefinite integral. Combine the second and the third terms and factor out 1/2. Fifth, express in terms of the original variable and then simplify. Refer to the trigonometric substitution rule we formulated earlier. The tangent of theta and the secant of theta have the following expressions. Note that the numerator can be expressed as the square root of the quantity x squared plus 10x plus 9, which is the expression before completing the square. Substitute these expressions into the indefinite integral. Combine these rational expressions using properties of fractions. Note that first term is product, while the argument of the function in the second term is a sum. Apply a property of logarithm. Note that the natural logarithm of 4 is a constant, which can be combined with the arbitrary constant c. Distribute the constant to each term. Therefore, the integral of the square root of the quantity x squared plus 10x plus 9 dx is equal to the product of quantity x plus 5 and the square root of quantity x squared plus 10x plus 9 divided by 2 minus 8 times the natural logarithm of the absolute value of x plus 5 plus the square root of quantity x squared plus 10x plus 9 plus c. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.